Hello dear students, in this session we are going to study about force of friction. Force of friction is very important in day-to-day life. For example, if we have to walk on the ground also, we need friction. If in the absence of friction we will slip. When you are moving in a car, for the motion of car also you need friction. Say you are applying brakes. If the car has to stop, there has to be a frictional force between tires and the road. Okay, frictional forces is a common force in all the machineries and all. Okay, what is friction? It is an opposing force that comes into picture when a body tries to move on the surface of another body, or when a body is moving on the surface of another body. Say there is a block of mass m, okay, and you have applied some force F, okay, or say there is a table, okay, and you have applied some small force on the table, okay, you have applied some small force on the table. Now the table will not move. You have applied small force on the table will not move. Okay, why it will not move? There will be an opposing force, okay, in the opposite direction. If you keep on increasing the applied force on the table, after some time the table starts moving. Correct na? If you remove the applied force, then table will not come in the opposite direction. Hope you can understand. See, there is a large block of mass m is placed on the ground. Say this is not a smooth surface, this is a rough surface, means there is friction. If you apply small force, then this mass will not move. Okay, why it will not move? There will be a force of friction which opposes the motion, which acts in the opposite direction. Okay, this applied force and frictional force, they balance out. Then if you keep on increasing the force, then after some value of force, this mass starts moving. Even when the block starts moving, there will be opposing force. How we will come to know? If we stop applying force, then that block moves, then that block stops. Okay, so friction is an opposing force which comes into picture between the surfaces. When a body moves on the surface of another body, or when a body starts moving, when a body tends to move on the surface of another body. Okay, what is the definition I have written? We'll see. It is an opposing force that comes into play when one body actually moves or even tries to move over the surface of another body. Okay, we'll study this friction in detail. There are different types of friction. One is static friction, another is kinetic friction. What is static friction? It is an opposing force that comes into play when one body tends to move over the surface of another. Hope you can understand. Okay, there is something called limiting friction. What is limiting friction? It is a maximum opposing force that comes into play when one body just starts moving on the surface of another body. Means what? I'll explain once again. Say you applied some small force, then there will be small force of friction here in the opposite direction. You applied small force, the frictional force is very small, because we say that static friction, force of static friction is self-adjusting force. Hope you can understand. There is a table, you applied a small force on the table. Actually, according to F is equal to ma, table should move. Correct na? According to F is equal to ma, acceleration of the table should be equal to F by m. The block should move, but why it is not moving? Because in the opposite direction there is a force of friction. Now you increase the force on the table. Now also table will not move. What does it mean? Even when you increase the force, frictional force also increases. Correct na? So that is why we say frictional force is a self-adjusting force. But as you keep on increasing the applied force on the table or the mass, okay, at some point the table starts moving. At that point, what is the maximum opposing force? That maximum opposing force of friction, we call it as limiting friction. Hope you can understand. Next, kinetic friction. What is kinetic friction? When a body is moving on the surface of another body, the opposing force which comes into play is called kinetic friction. Kinetic friction. So there are two types of kinetic friction. One is sliding friction and another is rolling friction. Now here, in the case of static friction, we know that force of static friction, this you remember, force of static friction is directly proportional to normal reaction, or maximum value of static friction is equal to mu into normal reaction. This mu is called coefficient of limiting friction. Okay, coefficient of limiting friction. FL stands for limiting friction. You have to remember this equation. FL, limiting friction, is equal to mu into normal reaction. Okay. Now here also kinetic friction, force of kinetic friction is directly proportional to normal reaction, or force of kinetic friction is equal to coefficient of kinetic friction into normal reaction. What does it mean? What does it mean? What does it mean? What is normal reaction? This is mg, correct? Now weight is acting downwards. Normal reaction is acting upwards. If normal reaction is more, force of friction will be more. Correct now? So that is the meaning. Then as far as rolling friction is concerned, okay, this is not there in the syllabus, but still rolling friction is also directly proportional to normal reaction, and it is inversely proportional to, rolling friction is inversely proportional to radius. So that is why, see, for heavy vehicles, tire will be very big. Why? If you increase the radius of the tire, if radius of the tire increases, rolling friction decreases, frictional force decreases. That is why heavy vehicles will have big tires in order to reduce friction. Okay. Then if I draw a graph of force of static friction or force of friction versus applied force, how the graph will look like? Say you applied some small force and there will be small value of friction. You increased the applied force, then frictional force also increases. As applied force increases, frictional force also increases, like this. Okay, the angle made by this graph is 45 degrees. Now maximum value of static friction, we call it as limiting friction. After that, this block starts moving. Once the block starts moving, the opposing force which comes into play is called kinetic friction. See, this maximum value of static friction is bigger, okay, kinetic friction is smaller. How can we understand this? Say for example, there is a car. So there is a car which is standing over here. Say the engine of the car, there is a problem with the engine of the car. Okay, then what we'll do? Say two people are pushing the car. Okay, two people are pushing the car. Initially, for the car to start moving, it is very, very difficult. You have to apply large amount of force on the car. Once the car starts moving, then the force that you have to apply in order to keep the car moving is very, very less. What does it mean? When the car is at rest, that means static friction is more. When the car is moving, the friction comes into place, kinetic friction. Static friction is greater than kinetic friction. Okay, and kinetic friction is independent of velocity. Okay, and kinetic friction is independent of applied force. Okay, so this is the graph of force of friction versus applied force. Now we'll study something called angle of repose. What is angle of repose? See, I'll take an example. Say this is one inclined plane. Okay, this is a horizontal surface. I have placed some block of mass here. Okay, I'll keep on increasing this angle of inclination of this inclined plane. At some angle of inclination, the block starts moving with some constant velocity. That particular angle of inclination, we call it as angle of repose. Okay, you keep on increase the angle of inclination. At one particular angle, the block just starts moving with constant velocity. Then we call that particular angle as angle of repose. We will derive an expression for angle of repose. What is angle of repose? It is a minimum angle of inclination of the plane, of the inclined plane, with the horizontal, such that a body placed on the plane just begins to slide down. Okay, now in the previous videos we have studied about inclined plane and we know how to resolve mg, correct? Now I have considered one inclined plane. Okay, so let us we have placed some mass here. Okay, mg is acting in this direction, mg is acting in this direction. So we will resolve this mg, one perpendicular to the inclined plane, another parallel to the inclined plane. We have done We have already done this resolution. Okay, please refer back in a lecture on inclined plane. Okay, if this angle is theta, this angle also will become equal to theta. So this will be mg this will be mg cos theta. This will be mg cos theta, mg cos theta, and this force will be mg sin theta. Okay, now this mg cos theta, because of this mg cos theta, so there is a normal reaction in this direction. So this is normal reaction. And now here this surface is rough surface, means there is friction. This is not a smooth surface. Previously what we have done, we have taken a smooth surface and we calculated acceleration of the block. Correct? Now please refer that video once again. Now mg sin theta is acting downwards, so therefore force of friction is acting in the opposite direction. Force of friction is always parallel to the surface of contact. See, this is the block, this is the surface of contact. Force of friction is always parallel to the surface of contact. Normal reaction is always perpendicular to the surface of contact. Okay, now so at angle of repose, this mass just starts sliding. Means what? Force in this direction, force upward is equal to force downward. Force along the incline is net force along the incline place is equal to 0, because the block just starts sliding. So here what is the condition? F is equal to mg sin theta. Now what you have to observe, as the angle of inclination increases, this opposing force of friction also increases. So therefore this force of friction is equal to maximum value of static friction, that is called limiting friction. Okay, so therefore mg sin theta is equal to, what is the equation for maximum value of static friction? That is equal to mu into normal reaction. Now what is the equation for normal reaction? You look at this. Okay, now in this direction, perpendicular to the inclined plane, mass is not going up, mass is not coming down. So therefore force in this direction should be equal to force in this direction. Therefore we can write an equation for normal reaction. Normal reaction is equal to mg cos theta. Normal reaction is equal to mg cos theta. If there is a horizontal surface, then mg will be acting downwards, normal reaction will be acting upwards, normal reaction will be equal to mg. But here normal reaction is equal to mg cos theta. What happens? mg sin theta will be equal to mu into mg cos theta. Okay, so mg gets cancelled. So mu equal to sin theta divided by cos theta. Mu is equal to sin theta divided by cos theta is equal to tan theta. Mu is equal to tan theta. So what this theta is angle of repose, because at that angle of repose the body of mass m just starts sliding downwards. Correct now? Tan theta. So therefore angle of repose theta is equal to tan inverse of mu. What is mu? Mu is called coefficient of limiting friction. Hope you can understand. So we have taken a rough surface. Okay, so we are increasing the angle of inclined plane such that this block just starts moving. If the block just starts moving, what does it mean? This force of friction is equal to mg sin theta, and this force of friction will be maximum, because this is the maximum value of static friction. After that mass is moving. Correct now? That we call it as limiting friction, and we know the equation for limiting friction, that is mu into normal reaction. So we should know what is normal reaction. So if you look at this diagram, upward force is equal to downward force, because in this direction this mass has got equilibrium. This mass is not going up, it is not going down. So therefore upward force is equal to downward force. N is equal to mg sin theta. We will substitute in the place of n is equal to mg sin theta. Mg gets cancelled. Sin theta by cos theta is equal to tan theta. So we get mu is equal to tan theta. Our angle of repose theta is equal to tan inverse of mu. Okay, hope you understood the topic. We studied what is friction. It is the opposing force when a body tries to move or moves on the surface of another body. We have studied static friction. Okay, it is the opposing force which comes into picture when a body tries to move on the surface of another body. We have studied static friction is a self-adjusting force. Correct now? Maximum value of static friction we call it as limiting friction. Equation for limiting friction is equal to mu into n. Then we studied kinetic friction. Equation of kinetic friction, Fk is equal to mu k into n. Correct now? Kinetic friction has got two types. One is sliding friction, another is rolling friction. Rolling friction is the least. Okay, out of, if you consider consider out of static friction, kinetic friction and rolling friction. Okay, static friction is greater than kinetic friction, kinetic friction is greater than rolling friction. Okay, rolling friction is the least. Okay, what is the equation for rolling friction? Rolling friction is equal to mu r into n divided by r. R is the radius. Okay, so that is why, as the radius of the tire increases, rolling friction decreases. Therefore, for heavy vehicles we have tires of very big radius. Okay, and we drew a graph of frictional force versus applied force. Okay, as the applied force increases, frictional force also increases. That is why we say that static friction is a self-adjusting force. Hope you understood the concept of friction. Thank you very much.